Hi kids, today we're going to look at an introduction to section 11.2. They are the negative and Pythagorean identities. And again, remember we're working towards being able to solve trig equations, but before we get there we need to know how to manipulate them a little bit. And so there's all sorts of identities that come into play. And I think these first ones you may have seen back when we were doing the day 1, day 2, day 3 intros to 11.1. So these Pythagorean identities, sine squared plus cosine squared is 1. Tangent squared plus 1 is secant squared. 1 plus cotangent squared is cosecant squared. I think you've seen them before. And remember, you can manipulate them to be different forms. So like say I have sine squared plus cosine squared equals 1. I could also say that the cosine squared minus 1 equals the sine squared. I can take that same equation and solve it for cosine squared and get 1 minus sine squared, and do the same with all of those. And I think I showed you that in previous videos. But here's the new ones you haven't seen. The negative angles. What if I'm looking at the sine of a negative angle? It equals the negative sine of the positive angle. Same thing goes with cosecant, because remember they're friends. They're reciprocals of one another. So the same rule applies. It would be a negative cosecant. But for cosine and secant, interestingly enough, they turn positive. For tangent, they're back to negative, and cotangent his friend, and here's why. Let me show you the picture. Here's the graphs. You remember these graphs. So if I go and look at a negative angle, this is the sine graph. If I look at a negative angle and I go the same amount away from this is 0, 0, the origin. If I go the same amount and look at a positive of that same angle, see here, they would have different signs. This would be a negative because it's below the x-axis. This would be a positive. So they change signs. So for the sine, they change signs. If I do cosecant, his friend, that one, here's my negative angle dotted here. If I'm at the origin and I go about the same distance over here, now I'm here. They change signs. The y values are opposites. If I go to cosine, cosine's this graph. Here's my negative angle. If I go about the same amount in a positive direction, look at that. They have the exact same y values. They're the same. The sign does not change. They both are positive. If I go to his friend secant, that's this guy down here. Secant, I dotted a negative angle. If I go about the same space on the other side, it's going to be about there. They have the same y values. That doesn't change. If I do tangent, this is tangent. Here's the origin. Go about the same amount over here. Different y values. One's positive, one's negative. Cotangent over here. If I go, this is my origin. If I go about the same distance away from the origin, this is my new dot, and you can say they have different signs. So it's all based off of the graphs that we learned back in the day. You can see the cosine graph, they have the same y value. The secant graph, they have the same y values. Everybody else changes to the opposite. They change by positive to negative, or if they're negative, they change from negative to positive. And so there are these new negative identities that are here. So what we're going to do today is use those identities, the Pythagorean identities and the negative angle identities, to be able to simplify and verify like you've been doing for the last several days. So let's apply the rules. I'll show you some examples. Secant of negative x. Secant changes, or changes to a positive. So this would be a positive secant of x. Cotangent, cotangent becomes negative. So this would be times a negative cotangent of x. So you apply the negative rules first, and then you take it from there and do the same thing we've been doing for the last several days. You would probably turn everything into terms of sine and cosine. See where that takes you. Secant becomes 1 over the cosine. Cotangent is a negative, this negative, cosine over sine. And you can see the cosine, 1 on top, 1 on bottom, they cancel. 1 times negative gives me a negative 1 on top, sine's on the bottom, and I know that negative 1 over sine will be the same thing as a negative cosecant. Alright, second one, number 2. I have a cosine squared x, and then I have this cotangent of x, cosine of x. I have 2 of them. I have 2 groups of them. And so because of that, I'm going to have a cosine squared x, this first one, plus I'll have 2 groups of the cotangent of x cosine of x and the cotangent of x cosine of x. Now you notice there's not a plus sign in the middle here. That's going to make things a little bit different. If I had a plus sign in the middle, I'd have to FOIL and do all that hot mess. But I don't have to do that for this particular problem. All I have are two groupings of that same thing. So when I simplify it, cosine squared x in the front, cotangent times cotangent gives me a cotangent squared x. Cosine times cosine gives me a cosine squared x. And I have two terms. Here's my first term, here's my second term, separated by the plus sign. So what I can do next is they both have a cosine squared x. I can factor that out. So if I factor out a cosine squared x, that's going to leave me with, take this away, leaves me with a place value of 1. Take the cosine squared away from this guy, I've got a cotangent squared. And so if I look up above, I see, oh wow, look, 1 plus cotangent squared is cosecant squared. So I can make that replacement. Cosine squared x times cosecant squared x. And then I change things into terms of sines and cosines. Cosine stays a cosine squared x. Cosecant becomes 1 over reciprocal sine squared x, which gives me cosine squared x on top, sine squared x on the bottom, and that is cotangent squared x. All right, let's try another. We're going to apply the negative rule first. Cotangent changes to a negative. So this becomes a negative. These are alphas. Cotangent of alpha. Secant of a negative angle becomes a positive. So times a regular old secant of alpha. Sine changes to a negative. So it's going to be a negative sine of alpha. Three terms I'm multiplying together. I have a negative times a positive times a negative, and ultimately everybody cancels and becomes positive. So I don't have to worry about the signs. They end up canceling each other out. And I'm ready to just change things into their sine and cosine equivalents. So cotangent becomes cosine of alpha over sine of alpha. Secant becomes 1 over cosine of alpha. And sine just stays sine. We don't change that. And I look at what happens. So I've got a cosine on top cancels with a cosine on the bottom. Sine on the bottom cancels with a sine on the top. And ultimately that whole thing just becomes a 1. So that's kind of nice. Secant of x minus tangent of x sine of x, nothing factors out. I can't use the factor out trick like I did in number 2. So I'm going to automatically just start changing things into sines and cosines. Secant is 1 over cosine. These are x's. Tangent is sine over cosine times a sine of x. And I look at that and I'm like, oh, wow, they don't cancel out. Sometimes they do, a lot of times they do, but this one doesn't. The one good thing, though, is that I've got two fractions I'm trying to subtract, and they both have cosine as their denominators. So I have a common denominator. My common denominator is cosine. This is a 1. There's a minus. Sine times sine makes this sine squared x. And then I look at my identities and I'm like, oh wow, didn't I just say that kind of up above here? I have sine squared plus cosine squared equals 1. If I have 1 minus sine squared, it equals cosine squared. And again, you have all the identities written out in their different forms from your notes from earlier in the day 1, day 2, day 3 thing. So this is 1 minus sine squared is actually equal to cosine squared over cosine of x. So I have 2 on top, I have 1 on the bottom, this guy cancels with the guy on the bottom, and I'm left with just a cosine of x, and that's my final answer for that one. Then they change up the rules a little bit, and they say, okay, now verify. I almost like those better because you know what you're trying to make them equal. It's not so up in the air. Again, there's no identities that I can apply. I don't have any negative identities. So all I can do is start trying to change things into sines and cosines and see where it goes. So tangent is sine over cosine. Sine of alpha, these are. Cosine of alpha. Cotangent is cosine of alpha over sine of alpha equals, hang on. My TV just turned on. Okay, so over here, if I'm secanting, he's 1 over cosine. Cosecant is 1 over sine. Those two things are being multiplied. Well, that didn't take me anywhere pretty, did it? So if I look on the left, there's not really much I can do on the right. The right-hand side is going to be 1 over the cosine of alpha times the sine of alpha. That's all I can do with that. There's nothing else. But this guy, I'm trying to add fractions, and we know if we want to add fractions, we have to have a common denominator. So my common denominator has to be one of each thing. It has to be a cosine of alpha and a sine of alpha. And then I'm trying to match. This guy has cosine. It needs a sine. So I'm going to multiply him by sine of alpha over sine of alpha, which means that ultimately my numerator is going to be sine times sine, or sine squared alpha. Second fraction has the sine, it needs the cosine, so this guy's going to get multiplied by cosine of alpha over cosine of alpha. Cosine times cosine is cosine squared. And that makes me do a little happy dance, because sine squared plus cosine squared is one of my identities from up above. It equals 1. So I can replace this whole numerator with a 1, and look at where that places me. If I replace that with a 1, cosine alpha, sine of alpha is still on the bottom. It's exactly what I was trying to verify. So I'm done. So it got a little messy with the fractions, but really in the end it ended up working out pretty good. Alright, last one on this page. I have a tangent squared. For now I'm going to leave that alone. I'm going down here because this one pops out to me. Tangent squared plus 1 is one of my identities at the top. Tangent squared plus 1 is secant squared. So the first thing I want to change this time is that denominator and see what that does for me. So I'll keep the tangent squared for now on the top. This becomes a secant squared. I'm supposed to have it equal sine squared x. If I start changing things to sines and cosines, before I do that, I want to just split this fraction up. I have a tangent squared x times a 1 over secant squared x, because see how the secant's in the bottom, tangent's in the top? I only want to do one thing at a time, so I'm just taking that fraction and splitting it apart. Supposedly it equals sine squared x. Now I want to change things to sines and cosines. If it's tangent squared, that's going to be sine squared x over cosine squared x. 1 over secant is cosine, so this would be a cosine squared x. And again, I'm ready to do the happy dance because my cosine squares cancel and I've got a sine squared x equals sine squared x. Alright, so you have just verified, oop, you lost my page here, let me move it up. Sine squared x equals sine squared x. You've just verified that one, and we have just a few to go. So if you flip over to the next page, here's my next one. I've got tangents and sines and cosines, and I don't see any identities that pop out to me. And so I'm just going to start changing things to sines and cosines and see where it goes. By the way, this is an equals, doesn't really look like an equals here, equals secant of x. All right, tangent of x, sine of x, plus cosine of x. Anything that changes is changing into a sine and cosine thing. So tangent changes into sine over cosine times the sine of x plus the cosine of x. Remember, we don't change them. It's supposed to equal secant. Well, secant, actually, I can change secant into 1 over cosine. Since I'm changing guys into sines and cosines, there it is. Okay, let's see what we've got. This fraction, they're multiplying together. Sine times sine is sine squared over cosine plus a cosine of x. This is technically over 1, right? It's supposed to equal 1 over cosine of x. Two fractions that I'm trying to add together, so I want to get a common denominator. Between a cosine and a 1, it's a cosine. This guy has it, stays the way it is. This guy needs it, he needs to turn into a cosine, so he's got to get multiplied by cosine over cosine. Cosine times cosine, got a plus sign, is cosine squared. Alright, ready to put on the happy dance, because cosine squared plus sine squared, or sine squared plus cosine squared, equals 1. And you are done. You have just verified that. This, my friends, is probably the most tricky one on the whole page, because this one now has a subtraction sign in the middle and a plus sign in the middle on this one. And I'm squaring them, which means I have to literally FOIL these out. Each one of them, I'm going to have 8 pieces. It's a big problem. So let me start with the first one. if I do sine of x minus cosine of x, and I have two of them, sine of x minus the cosine of x times another sine of x minus cosine of x, what does that look like when I FOIL? So I'll have sine of x times sine of x first give me a sine squared x. If I go outers, sine of x times a negative cosine of x is a negative sine x cosine of x. If I do inners, negative cosine times positive sine is a negative cosine sine, and negative cosine times negative cosine is a positive cosine squared. All of that is just this first piece. All right, then I have a plus sign. And now I'm out of room on this side, right? So I've got to go. I'm going to put a whole other set of parentheses just below it. And now I'm going to do the same thing with this. This plus sign is this plus sign. Now I'm here. These are now pluses. What does it look like when you FOIL that? So firsts give me sine times sine, or sine squared. Outers give me sine times cosine, plus sine x cosine of x. Inners give me cosine of x sine of x, plus cosine of x sine of x. And lasts give me plus cosine times plus cosine is plus cosine squared x. And all of that is supposed to equal 2. Can you imagine, right? So remember, this is all one big thing. I just kind of wrote them underneath because I ran out of space. But I have a negative sine x cosine x. That's going to actually cancel with the positive because I'm adding those pieces together, negative, positive. Same thing happens with these guys. These are like terms. They're going to cancel out. So what I really have in this top set of parentheses is a sine squared x plus a cosine squared x. You should be having bells ringing right now. Sine squared x plus cosine squared x. Oh, there's a plus sign in the middle. Whoa, whoa, whoa. Plus. That plus is in the middle. Second set of parentheses, sine squared x plus cosine squared x. And that whole thing's supposed to equal 2. And here's why the bells are ringing. Because we know from the identity of Pythagorean identities, sine squared plus cosine squared is 1. So I have 1 plus 1. Look at this, pre-calc. 1 plus 1 is 2. And there's your answer. All right, next one. Remember, we're not allowed to cross the equal sign with these things when we're trying to verify, but we are allowed to do rules that as long as we do the same thing to each piece, it would it'd be a viable math move. So for this one, the actual identity that I'm thinking of, that this one reminds me of a lot, is the cosine or cosecant. And actually, the identity says this: 1 plus cotangent squared equals cosecant squared. See how I have all the pieces of that? But I'm not allowed to move things across the equal sign. So I'm trying to verify and keep things on one side. If I see this cotangent squared, if I take this identity and change it to cotangent squared, what would cotangent squared equal? Well, cotangent squared, if I get this alone, the 1 has to come to the other side. So it would equal cosecant squared x minus 1. Well, you see this is really similar, but the signs are different. So let's see what would happen if I literally every piece multiply by a negative 1. And again, that's a valid math move because I'm not crossing the equal sign. I'm just doing an operation to each piece. That would make this a negative 1. That would make this a plus cosecant squared x. And that would make this a positive cotangent squared x. Well, did we match it up? This is a positive cosecant and a negative 1 equals cotangent squared, and so there it is. Cotangent squared x equals cotangent squared x. All right, so that was a lot easier if you can remember the identity and you saw that you had all the right pieces. They just didn't quite have the right signs. So we did a trick, multiplied everybody by negative 1, and ended up with the identity that we wanted. Here comes the last one. I have sine, I have cotangent, cosine, cosecant. I have no screaming identities that are looking at me, so I'm just going to change everybody to sine and cosine and see where it goes. Sine stays sine. Cotangent becomes cosine over sine. Times another cosine. Oh man, they don't cancel out. Equals cosecant, which is 1 over the sine. So everybody wants sine and cosine. Well, let's see if we can clean it up a little bit. I've got the sine of x plus cosine times cosine is cosine squared over sine. And supposedly it equals 1 over sine. Well, again, I'm trying to add two things. I got a fraction involved. This guy has a 1 as its denominator. I'm getting common denominators between 1 and sine as a sine. This one doesn't have it. It needs it. I need to multiply by sine over sine. Gives me sine squared. Can you see where this is going? This guy has it. He doesn't need anything. Do you see it? Do you see it? Sine squared plus cosine squared. That's the identity. It equals 1. And you have now verified that particular identity. All right, so this is section 11.2, the intro. You're going to watch the next video from Flip Math and be able to do the practice problems, and I'm going to give you some examples from the practice problems that I will post as well. So email me if you've got any questions. I hope you're all doing well, and I miss you, and I'll talk to you soon. Bye.